Hello students, Mr. McCue back here on page 4 of section 9.7. Here we are going to go ahead and keep working with the same example. I know this is getting just a little bit repetitious, but when you can see the correlation that if you take the quadratic equation, x squared minus x minus 12, this time it's going to be less than 0. We simply are going to follow the 3 steps that we described before. Take the quadratic equation, set it equal to 0, and find the roots, which again are -3 and +4. And keep in mind that really, when you look on these notes here, I put solid circles, but we really got to remember that is really open, because you're not going to include those on there. Okay, so just keep that in mind. Those need to be open. And now the question is, can we figure out which interval? And don't forget, we're going to test for b, because that's the middle one, and we're going to try to use x equals 0, because that is the easiest one to stick into the quadratic equation and find a value for it. Now usually when x equals 0, it's in the middle, the b interval, but not always, so double check that. So I like doing the pseudograph idea. You draw the x-axis, you find the roots, put your open dots here. Again, you know the graph is going to open up, so it's going to come down. The vertex will be down here, and it doesn't matter where at, as long as you know it's below the x-axis. If you wanted to, you could put a little y-axis here if you like that visual. And so here we go. Step 3, test for the inside or middle interval b with x equals 0. Simply plug it in, and this time we find out that once you plug it in, -12 is less than 0. Is that a true statement? And lo and behold, we say yes, it's true. Okay, so you found a solution. It's the middle, or the b, and then you go back up to your graph. And so where is the solution going to be for the b, or the interval? And it's between -3 and +4, because it's the lower half of the parabola. Okay, with that said, you simply come down there. You might want to write it in that notation, but my math lab will want it in an interval, and you'll put parentheses because you do not include the -3, and you put the comma, and finally you put the 4, and you're putting parentheses here because you do not include the values. Okay, so that takes care of that concept. It's fairly easy once you get the concept of the pseudo graphing, and you know the graph opens up or down. And then we're going to take a look at example 3 here to finish up the second half of page 4 notes. And this is working with the case of what happens if you were going to graph a binomial squared and it was greater than or equal to -1. And you want to stop and think about this for a second and notice the parentheses squared. And perhaps you want to recall that any positive number squared is a positive number, is greater than 0. And any negative number squared, is also greater than 0 because of the squaring property. And so how can you have a result that's going to produce a -1? That's what they want you to see here. When you think about that for a second, you realize you do not have any numbers in here that would be -1. And so the solution is going to be all real values can be greater than -1. So -infinity to +infinity is going to be your solution. Okay, so again, when you look at this notation, they throw that -1, it's throwing you, but can you guarantee that it's going to be greater than -1? Absolutely, because any number squared will be greater than 0, which is, of course, 0 is greater than -1. Okay, so therefore it's all solutions. And then the converse of that is to turn around and look at the exact same problem and realize they're going to say what values are less than -1, and then you realize there can't be any, because any number squared will be greater than 0. So therefore you don't have to do any work. You can just say the solution is the empty set, that there is no number that when you square it can be less than -1. Okay, so there we go. That wraps up page 4. We're cruising through this concept pretty quick. We're going to move on to page 5, and we're going to work with cubic polynomials with the degree 3. Okay, that's Mr. McCue here for now. I will catch you on page 4.